Factor and simplify is one of 6 algebraic manipulations you can use when evaluating limits algebraically. You guys, this is one of the most popular twists on this type of problem. I see it come up all the time on homework, quizzes, and exams. The strategy for evaluating limits algebraically will be to first try direct substitution. Always. But if that fails, which it often will, we want to think of factor and simplify as one of the tools that can help us proceed in finding the limit. Let me show you an example of how it works. So here we have a limit, and we always want to try using direct substitution just in case, because if it does work, it's really convenient. We can find the limit really quickly. The limiting value is 3, so direct substitution, I'm just going to try plugging in that 3 into every x that I see on the inside of the limit. And you might recognize this limit from the previous video. When we talked about direct substitution, we showed that it doesn't work. And the reason is because we get this 0 in the denominator at the end, and we can't have that. So direct substitution is not going to work, and we're going to need a new technique in order to get unstuck here. And that technique is exactly going to be factor and simplify. So let me show you how to use factor and simplify to get through this limit. I'll start by rewriting the limit over again. And you might be asking, why is he doing that? Well, I'm trying to indicate to everybody that I'm starting over. I'm trying something different. In the first sentence that I wrote down, I was explaining, hey, I'm using direct substitution. It's not working. I'm getting a 0 in the denominator at the end. And in the second sentence, I'm starting by saying, okay, I'm starting again. So I rewrite the limit over again. And now I want to recognize that there is something that can be factored in the numerator. And that's really important. You always want to look out for something that's factorable. In general, if there is something that factors, you can usually factor it and something special will happen to help you get through the limit. So always look out for things that are factorable. And what I'm going to do is factor it from that step to this next one. I'm going to factor that numerator, and that factors into x minus 3, x plus 2, all over x minus 3. Now, before we go further anymore, I want to talk a little bit about why this limit symbol from step 1 to step 2 here, why did it not go away? Because if you remember in the previous sentence, I dropped that limit symbol between the first and the second step. And the reason that I dropped that limit symbol was because I plugged in the limiting value. In fact, I'm not going to drop the limit symbol until I have plugged in the limiting value. And from this step here to this step here, I have not plugged in the limiting value of 3, so I'm not going to drop the limit symbol. It's just going to hang out there on the outside. I have only changed the way that the inside of the limit looks by factoring the numerator. Okay, so let's proceed. How do we go from here? We have it factored now, and notice that there is an x minus 3 on the top and the bottom. That factor will cancel. So that binomial factor that's common to both the numerator and the denominator of this fraction on the inside of the limit will cancel each other out. And that leaves us with the limit as x approaches 3 of just x plus 2 over 1. Notice how, again, I'm carrying through that limit notation in the front because I have not plugged in the limiting value yet. Not until this step, that is. Once you've done this factorization, this is really the key here. Notice that in this first mathematical sentence here, when I was plugging in the limiting value of 3 and for every x that I saw, plugging it into the denominator was really causing the 0 to appear there. The 3 minus 3 on the bottom was coming up, which was getting me the 0. But notice that now that I have canceled that x minus 3 factor on the bottom, now there is no issue of getting a 0 in the denominator. So what I'm going to do is I'm going to try plugging in the limiting value again. I'm going to try taking that 3 and plugging it in to the remaining x's that are on the inside of the limit. And when I do that, I get 3 plus 2 over 1, which of course reduces to 5, and that is indeed the limit. Through the process of factoring that numerator and canceling that binomial x minus 3 on the top and the bottom of that fraction, I fixed the problem of the 0 in the denominator that was coming around when we were trying direct substitution in the beginning. So, our general strategy so far is if direct substitution fails and you see something that factors, then try factoring it. Be prepared to factor a difference of squares, a sum or a difference of cubes. I mean, I've even seen factoring by grouping come up from time to time. The more comfortable you are with factoring, the more comfortable you are with this twist. But remember, factor and simplify isn't the only algebraic manipulation you can use when direct substitution fails. A second option to consider when direct substitution fails is expand and simplify. Sounds very similar to factor and simplify, but it's expand and simplify. Join me in the next video twist to find out more about this expand and simplify, this second algebraic manipulation.